In this video, you will learn how to subtract polynomials. In the first example, we will model the subtraction of polynomials using algebra tiles. To subtract polynomials using tiles, we begin by modeling the first polynomial. So negative 3y squared are three unshaded big squared tiles. Then we model positive 2y, so two shaded rods. And we model the constant term negative 5, so 5 unshaded unit tiles. Our next step is to simply take away the terms in the second polynomial. So we got to take away negative 2y squared, we have to take away negative 4y, and we have to take away positive 1. So we can, by looking at our tiles, we can subtract negative 2y squared because we have enough to do that. Next, we need to take away negative 4y. But when you look, you aren't modeling any negative y tiles. So your next step is to add zero pairs until you have enough to take away negative 4y. So we add in one zero pair. That isn't enough yet. Add in another zero pair. Remember, a zero pair is one positive and one negative tile of the same shape and size. This still isn't enough to take away negative 4y, so we add in another zero pair, and one more zero pair allows us to now take away negative 4y. So we just circle them, put an arrow showing that we're taking them away. And then the last term that we need to take away is a positive 1. We aren't modeling any positive unit tiles, so again, we must use zero pairs. So we take in one positive and one negative unit, and this allows us to now take away positive 1. Our final step is just to write the simplified polynomial. So we have one negative y squared tile. We have 1, 2, 3, 4, 5, 6 positive y tiles. And we have 1, 2, 3, 4, 5, 6 negative unit tiles. Again, remember that we don't write 1 as a numerical coefficient. We can simplify that further as negative y squared plus 6y subtract 6. So when we subtract those two polynomials, this is our simplified answer. Let's look at an example now where we just do it symbolically. Okay, so our first step is to remove the brackets. So the first polynomial just goes written down as it is, so that one's easy. But we need to remember now that we are subtracting every term in the second polynomial. So we are subtracting negative 2y squared. We are subtracting negative 4y. And we are subtracting positive 1. So we can just write down subtract 1. There's no need for the positive sign there. So our next step is to group like terms. But before we do that, we should get rid of any double signs. We should clean this up by getting rid of double signs. So there's only one sign here, one here, one sign here. But if you look here, we have two signs. And you've learned in previous grades, instead of subtracting integers, or subtracting polynomials in this case, we can add the opposite. So we're going to add, and the opposite of negative 2y squared is positive 2y squared. Right here we also have double signs. So instead of subtracting, we are going to add the opposite. And we only have one sign here, so we're okay. So we can go ahead now and group like terms, starting with our y squared terms. So we have negative 3y squared. We have positive 2y squared. We can move on to our y terms now. So we have positive 2y. We have positive 4y. And finally, we can write down our constant terms. Negative 5 and negative 1. I like to put a line under my like terms to remind myself I can only combine like terms. So I can combine my y squares with y squares, y's with y's, and my constant terms with constant terms. So, negative 3y squared plus 2y squared is negative 1y squared. Positive 2y plus 4y is positive 6y. And negative 5 subtract 1 is negative 6. And we will rewrite this to get rid of the numerical coefficient of 1, or just to write it in its simplified form. And this last line is our simplified polynomial. This concludes our lesson on subtracting polynomials.